Good day, we are Group 5 and this is our project simulation. A Colpitts oscillator was invented in 1918 by American engineer Edwin H. Colpitts. It is one of a number of designs for LC oscillators, electronic oscillators that use a combination of inductors and capacitors to produce an oscillation at a certain frequency. In this simulation, through the use of LT-Spice, we expect an output voltage value of 3 RMS voltage of less than 60 Hz frequency. Values used were as follows: DC supply of 7.7 volts and AC stimulus value of 1. The first resistor contains 100K ohms, R2 of 407K, R3 of 6.2K, and R4 with 3.2K. The transistor model of BC547B, while the first capacitor has 22 microfarad, C2 of 5 microfarad, as well as C5 with 5 microfarad. In the LC tank circuit, we have L1 or the inductor to be 1 millihenry, C3 and C4 in parallel, both with a value of 1 microfarad.
For the simulations, the first one conducted is a transient analysis, which is run with the following settings. So for our stop time, we have 1.1 second. Time to start saving data is 0.1. A maximum time step of 1 microsecond. And we will enable this option to skip initial operating point solution to make our simulation faster. With that, we're going to run our simulation. To find our output voltage, we just put our pin on the output node. And once the simulation has ended, we can determine the RMS value of our voltage output. Just click on your control button, then on the label of the plot. So in this case, our RMS value is 3.022 volts. So in terms of the output frequency, Riley will explain the simulation process for it.
To determine the frequency of our output waveform, we need to do a frequency response analysis. The simulation settings were as follows. The type of sweep is octave and the number of points per octave is 100. Start frequency is 1 and stop frequency is at 1000. And the reference dB point can be determined by clicking the control button plus the plot label. And we have a reference point of negative 9.443 dB at the minus 3 dB point. We can get the frequency of our output, which is approximately equal to 11.24 Hertz.
To sum up our results, we had an output waveform of 3.0022 VRMS with a 11.24 Hz frequency. That's all. Thank you for watching.
Thank you.
Thank you.